Hi, I'm Vishwak. I'm from Carnegie Mellon University, and I'm here to talk to you about linear algebra and PyTorch. So it's one of those few things that you probably won't be using PyTorch for, at least since before 1.0. But we have made some amazing strides in improving the experience for you as far as linear algebra goes. So what's new in linear algebra since 1.0? We have native batching support. So before 1.0, you'd be writing like big Python code to perform a batch Cholesky or batch QRT composition for you. In 1.2 and 1.3, we have all of these written as just one-liner. So you don't need to have to write all of this complex Python code to perform a batch operation for you. So we have batching support for a bunch of your routines. You have solve, almost all of the solve methods. You have factorization routines. You have inverting routines as well, and some spectral operations such as determinants and log determinants. We also have support for gradients for almost all of your operations. So you don't need to write hacky wrappers around, say, solve to backprop through Cholesky solve, which is a much more efficient implementation of solve in special cases. And the most important change that I have in store for you is new semantics naming schemes. LAPAC did an amazing work of providing us a very generic naming scheme. You had very interoperable naming schemes for complex operations expressed within 5 letters, right? But when you're talking about PyTorch and conversation, you can't really go and tell, hey, I did TRTRS on a triangular matrix with another big batch of matrices, right? It's better if you say something like triangular solve. I performed a triangular solve on a triangular matrix with a right-hand side matrix. So we have new semantic naming schemes for multiple operations. So for example, your bitrefact, which is exactly your LUG composition, has been renamed to LU. You have bitrefact with info, which was a separate function in PyTorch 1.0. We have implemented a getInfos argument to LU that will allow you to get the information, therefore superseding bitrefact with info. You have bitresolve renamed to LUsolve appropriately, and you have bitreunpack renamed to LUunpack. Gels, it's not gels, it's least squares, so LSTSQ is a more appropriate naming scheme. And then we have GSV, which is your general solve. We can rename it to solve, following a lot of recent linear algebra packages that have come out. Portref has become Cholesky. Portree has become Cholesky inverse. Portress has become Cholesky solve. And TRTRS, as I said earlier, is triangular solve. And so I thank everyone for staying back for the talk. And thanks for listening to me. If you have anything that you would like to have in PyTorch as far as linear algebra goes, please feel free to talk to me or create an open issue on the GitHub, and we'll be happy to discuss it with you.